Okay, welcome back. Here we are back in 5.3a. I'm just going to wrap up problems numbers 18 and 20 on this short video. And this is a section where we're finding all points of inflection, which is just a screaming cry for us to find second derivative and work with this guy. So let's take a look. First derivative is a product rule, so I want the plain old first x to the 1/2 times the derivative of the second plus the derivative of the first 1/2 x to the negative 1/2 times the just plain second. And let's see how that cleans up. I get x to the 1/2 plus, I guess I'm going to write this. I think I might. Should we product rule this? Should we quotient rule? Well, let's go ahead and see what happens if we get common denominators here. This is one of those cases where we may come back and stick with product rule, but I'm going to go ahead and write this as just x plus 3, didn't really need the parentheses, on 2 times x to the positive 1/2. And now I'm tempted to go ahead and get common denominators. So if I multiply this first term by 2x to the 1/2 on 2x to the 1/2, I get 2x plus x plus 3 all on 2x to the 1/2. 2x to the 1/2 times x to the 1/2, of course, is just 2x. So maybe that's not too bad to work with. We get 3x plus 3 on 2x to the 1/2, and that is y prime. So we're on our way now to find y double prime, quotient rule. Excuse me. So we've got y double prime equals low, d high, derivative of high is 3, minus high, all of 3x plus 3, d low, that's 2 times 1/2, or 1x to the negative 1/2, all on 2x to the 1/2. So let's see where that gets us. Now we got a little bit going on here in the numerator. I'm just going to clean that up. I got 6x to the 1/2, and I've got a minus. I think I'm actually going to factor this 3 out of here just for a second. See what happens. I get 3 times x plus 1 times x to the negative 1/2 on 2x to the 1/2. Now we got some options here, but I am really tempted to multiply top and bottom of this by x to the positive 1/2. And that would clean up this mess. In fact, that would clean up this, and that would clean up this as well. I'm kind of pinching myself out of room here on number 20. I may come back and regret that. So let's take care of that. As I distribute x to the 1/2 to this, I just get plain old 6x minus, I'll keep this as 3 times x plus 1, and x to the 1/2 times x to the negative 1/2 is just 1, all on 2x. I think that was a good decision. So we've got 6x, cross that out. I guess I'll distribute this guy back in. 6x minus 3x, 3x, and a minus 3, all on 2x, the second derivative. Could it be that easy? Okay, so we want to find out when that slope equals 0. Slope equals 0 when x equals 1. And we want to find out when this is non-differentiable. This is non-diff when x equals 0. If we go back up and take a look, I realize since I have a square root of x right here, that x has to be greater than or equal to 0. So 0 is okay, but because 0 is an endpoint, 0 could be a maximum or a minimum, but it could not be an inflection point. We can't switch from positive to negative. All right, so I'm putting this in. 0 is an endpoint, and I'm just going to check build around 1 into my second derivative. So if I put a value bigger than 1, like 2, into my second derivative, I get 6 minus 3, 3 on 4. More importantly, I get positive on positive. And if I put a value to the left of 1, like 1/2, I get 3 halves minus 3, that's a negative. 1/2 times 2, positive. So we are changing from concave down to concave up at 1, so we have an inflection point of 1. I'm going to go all the way back up top and put 1 into my original function, and I get 1 times 4, square root of 1, 1, times 1 plus 3, 4, 1 times 4, 4. So for number 18, we end up with the point 1, 4. And kind of nice. This is a really huge step for me as far as algebra, and I initially recognized the possibility of doing that to clean up this x to the negative 1/2, but it really paid off. That's what made me follow through with it, because it cleaned up a lot of other things as well. Okay, now this could be a problem after I get started on 20, that I might want to come back and treat this like y equals x times x squared plus 1, and twice take product rules instead of quotient rule. But I'm going to start this with quotient rule. So I get y prime equals low d high minus high d low. I think I'm going to do this to save some room, over the square of the thing below. So that simplifies nicely into, let's see, I've got an x squared up top minus 2x squared. I get a minus x squared and just a plus 1 on x squared plus 1 squared. Okay, so far not so bad. We're going to try second derivative, and I expect this to get a little bit uglier before it gets good again. Y double prime low is now x squared plus 1 squared d high times negative 2x minus high negative x squared plus 1. D low is 2 times x squared plus 1 to the first times the inside derivative 2x. Y double prime equals, all of that, by the way, guess I'm going to have to go here, is on the square of the thing below, x squared plus 1 now to the fourth. All right, numerator, negative 2x times x squared plus 1 squared. Then I've got a minus, a 2 and a 2x, so minus 4x times negative x squared plus 1 times x squared plus 1, all on the square of the thing below. And so at this point right now, I think I'm going to grab another piece of paper here, because I think I need some room where I invaded. At this point right now, I think I'm going to go ahead and try to see what factors I can get out of the numerator, because I've got this thing. I don't see a real benefit in foiling everything and combining terms, because I'm going to end up with a 5th degree polynomial here, and I'm not so good at factoring those. So let's see how this goes. Y double prime equals, from this first term, I can take out a negative 2, and I can take out a negative 2 from this second term. So negative 2 comes out. They both have factors of x. They both have at least a factor of x squared plus 1. So to get from here back to here, I'm just missing an x squared plus 1 factor. Put it in parentheses just to emphasize that. To get here, I've taken out the minus. I've taken out a 2, leaves me with a 2. I've taken out the x. I've taken out the x squared plus 1, and I'm left with a negative x squared plus 1. All on, just waiting around. This is to the fourth. X squared plus 1 to the fourth. One more step cleaning up. Maybe at least one more, I should say. Let's see, I've got a negative 2x factor. I've got an x squared plus 1 factor. And inside of parentheses here, if I distribute carefully here, I get a negative 2x squared plus an x squared, a negative x squared. I get a 1 plus a 3 of it, or 2 eventually, plus 3, all on x squared plus 1 to the fourth. So now, when is our slope 0? Well, x is a factor, so when x equals 0, This would lead to x equals plus or minus square root of negative 1. So that doesn't give me any. But this would lead to plus or minus square root of 3. And wonder about that value of 0. So those are the values I'm going to put in. How about non-differentiables? Nope, I can't get a negative, or I can't get a 0 down here in the denominator, so we have no non-diffs. None. Therefore, next thing I might want to do, check endpoints, but I can put any values I want because I can't get 0 in the denominator. So this is a continuous curve. I'm interested in what happens around 0, around root 3, and around negative root 3. So, seems like a mess, but let's see what happens here. When I put, are those my values? Yep. When I put, let's start with 1. When I put 1 in here, let's keep track. This becomes negative. So I got a negative. Let's use this space over here. A negative. This becomes positive. When I put a 1 in here, this term is positive, and the denominator is positive. 1 negative, it's negative at 1. How about negative 1? Negative 1, cross that out. Negative 1, I get a positive times a positive. Negative 1, this is still a positive. Negative 1, that's 1, 2, positive. All positives, I'm positive in here. 2 is to the right of root 3. So cross that one out, put 2 in here. I get negative when I multiply by negative 2. I get, put 2 in here, positive. Put 2 in here, and I get negative. Put 2 in the denominator, positive. 2 negatives, positive. I expect negative here, but let's see. Put negative 2 in here, this term becomes, don't know why I did that. Oh yeah, I do. So I'll do it again. This term, put negative 2 in here, this term becomes positive. Put negative 2, this one's positive. Put negative 2 in here, and I get negative 4 minus 3. This one's negative. Put negative 2 in here, denominator becomes positive. So this is negative. These were slopes of 0. Therefore, I have inflection points at root 3 something, at 0 something, and at negative root 3 something. So I go back up, take these guys back up top. We have room there. We have room if I fold it. Take these guys right back up to my initial function. And I want to put root 3 in here. And I get root 3 on root 3 squared, 3 plus 1, 4. 0 gives me 0 on 1, 0. And negative root 3 gives me negative root 3 on negative root 3 gives me 4 in the denominator. So there we have it. Not so bad. We're just going to run into some algebra on these last couple types of problems. To be honest, I wouldn't feel completely guilty putting a problem like 18 or 20 on the test, but I sure wouldn't load it up with problems like those. But I think we ought to be able to work through that. Okay, hope that's helpful, and stay tuned.